Well, hello everybody, and let's review. So the test has two parts, the no calculator part, which is the majority of the test, and then there'll be a few questions on the calculator portion of the test. As you can expect, unit circle values are kind of a big deal. So time's up. I hope you know them. You may not see just plain unit circle questions. They're more like 7 through 10 on here, but just kind of to help you kind of practice it again for those of you that kind of haven't done it in a while. However you're going to do this, if you're going to draw the first quadrant, if you just know what pi over 3 is, of course you have the ability to look these answers up. But just to go through these, of course, this really goes with cosine, which is down here. So when we flip over 0, that's undefined. And then cosecant, we really do sine. Pi over 6, of course, we flip over the 1/2, and that's a 2, but it's negative because of the third quadrant. For your graphs, the questions are pretty standard. It's not supposed to be a trick, but it might feel like that. That amplitude question, most of the graphs don't have an amplitude, but you may, just because the questions are the same, you may be asked that. So this, of course, has no amplitude because it's tangent. Your period, be careful with this. Period is 1 pi over b, as a reminder. So our period here is just pi. And we do have a vertical shift of down 2. Please don't write a -2. Don't just give me the question. Interpret what it means, please. So let's graph this. Remember, for tangent and cotangent, you're going to graph for 2 cycles. So in order to help you out and make sure you have space, we're going to double that period. So there's your 2 pi. I know the period's 1 pi. We want to double it so we have enough room. Also, you need to show that it moved down 2. So here's your new midline. You don't really need to have anything else. Like if you want to have other numbers on that y-axis, you're more than welcome, but it is unnecessary. And then, of course, we're not moving this left or right, so we know that the tangent starts 1 space to the left of the y-axis. If you do not start it there, that is not the tangent. So be careful with that, unless, of course, it moves so far that it's not there. Then it goes asymptote, 0, asymptote, 0, asymptote. And your zeros should be on your new midline. Please draw your asymptotes long enough to show how it bends the graph. For number 6, of course, not supposed to be a trick. It's just a question. There is no amplitude here, but we do need that 3. Period is, of course, 2 pi now over b, or 2 pi over 2. So the period is 1 pi. This thing is moving to the right. Ooh, tricky. Look at this. I love this. So it's pi over 2, and then we're going to divide that by 2, right? Be careful with just doing pi over 2 over 2. What are you doing there? So that's hard to work with. So this is really going to be pi over 2 times 1/2, or pi over 4. That was super tricky. And of course the vertical shift is up 1. Oh, and it reflects. Oh my goodness, this thing is got all the things. Now you're not really asked about that. I just wrote it down to kind of help remember what was happening. Oh, we're going to run out of space here. So we're moving this right pi over 4. Let's see how far that is. So the period, 1, 2, 3, 4, pi. Oh, so it's 1 space, right? 4 spaces got me to pi, so we're going to need 1 more space out there. We do have to pay attention to the up 1. And we need this line. And then even though there's no amplitude, there is an amplitude for cosine, we're going to need to see this, and then down 3 as well, -2. I'll try to get rid of some of this. We don't need this. All right. I'm going to graph it and then move it. For those of you that need to see that, if you don't take 2 steps, then don't take 2 steps. But I'm going to graph it. I'll graph it in green, and then I'll move it. So I'm going to reflect it. So it's cosine, so it's going to start low. This is supposed to start high, and the low and the high switch. It ends high. I'm sorry, it ends low now because it's reflecting. And then from the midline, we're going to count up 3. And then the zeros, of course, live right on the midline. So these green dots are like the graph that's going to slide 1 space to the right. So if I take each dot and slide it 1 space to the right, I'm essentially moving this right pi over 4. And of course, there's your cosine graph. We're not even graphing cosine. So we don't need to draw that. You can if you want to. If that helps you, the cosine graph should live kind of in peace with the secant graph. It should not interfere with your secant graph, so if that helps you kind of draw it. So the zeros become asymptotes. We have another one here. And so this high point is basically telling you, hey, only draw it higher. And these low points also only draw lower. And what I mean is that the cosine lives inside here, so your arrows should not cross over your cosine graph. So if it helps you to have that cosine graph inside there, then please draw it in. This is more like the plain unit circle questions you'll see on the test. Some inverse and some straight up kind of mixed together composition of functions, if you will. Where does the cosine equal 1/2? We are going to do this. Now, cosine only lives in the first two quadrants. We're doing this with principal values, which means the strict use of the domain and range the way it was defined. So this will just be pi over 3. We don't use these other two quadrants. Same thing with all the rest of these. So where is the sine of positive 1/2? That's pi over 6. And then you're asked for the cosine of pi over 6, which is, of course, radical 3 over 2. What angle has a tangent of positive 1? Well, that would be pi over 4. And then, of course, what is the cosine of pi over 4? What angle has a cosine of radical 2 over 2? Well, that's pi over 4. But we got to multiply that by 2. And of course, the tangent's out here. So now the question is, what is the tangent of pi over 2? Well, that's up and down, so the tangent is undefined. Solving, expect all three types of solving: general solutions, radians, degrees, and then, of course, radians and degrees on the calculator portion. Lots of factoring. All right, we got a trinomial here. In order to split this up, remember, we don't touch the angle. It's going to stay theta. If you don't like theta, you can use x. Two numbers and multiply to give you 2. Well, that's not a lot of choices. And then when we put those together, add or subtract, we get a -1. So that's going to be a -2 and a +1. So here we have that the cosecant equals -1, and the cosecant equals 2. I sort of skipped the equals 0 part and just moved my numbers over. Let's do the reciprocal. Cosecant, so if we think about 1 over cosecant, don't write it like that. That's not really very helpful. It is the sine of theta. Reciprocal of that is itself. Here we have the sine of theta equals 1/2. Take a look at your domain real quick. So we're 0 to 2 pi. Sine equals -1 at 3 pi over 2. Now, for this, we're allowed to use the entire unit circle. So we're going to use all 4 quadrants. Sine is 1/2 at pi over 6. Not sure why I wrote that. And then, of course, in the second quadrant as well, 5 pi over 6. With this one, for number 12, they have a sign in common, so we'll take that out. Just regular GCF. That's a 1. Sine divided by sine is 1 minus 2 cosine x. Now we'll set each factor equal to 0. I know I skipped that step in the first one, sorry. Where does the sine equal 0? Well, 0 and pi, of course. And then here, we can have a -2 cosine x, move that 1 over, divide both sides by -2. And the question is, the cosine equals 1/2. So what angle has a cosine of 1/2? 2 spots. First quadrant's pi over 3, and of course then all scholars take, so down here in the fourth quadrant, which is 5 pi over 3. Still on the non-calculator part, again, the non-calculator part is definitely 2/3 of the test. Tangents. Oh, just another GCF, right? So we'll just take out the tangent of x. So we're left with tangent of x plus 1. Set each factor equal to 0. Tangent of x equals 0. Tangent of x plus 1 equals 0. So tangent equals -1. The tangent is 0. We're in degrees now, 0 and 180. And the tangent equals -1 along this line. And that is your pi over 4 line. So 180 minus 45, 135. And 360 minus 45, 315. calculator portion. Kind of a weird question for the calculator portion. It could be on the non-calculator, but a question like this will be on the calculator part. Again, just to make it kind of balanced out a little bit. Before you go to draw, I'm going to draw this before I try to describe it, because it's a little bit hard, I think, to describe, right? So we know that the tangent has a period of pi. And you have to take that period of pi and we have to split this up. Halfway here, halfway here. So it starts at negative pi over 2 and it goes to positive pi over 2. And that's how we get our period of 1 pi. So the asymptotes are at negative pi over 2, pi over 2, and then again they'd be right here, 3 pi over 2, and we can start to see a pattern. It would probably be negative 3 pi over 2. So we're supposed to write an equation for all of them. So x equals, it's definitely pi over 2, and then we'll put the k. K is an odd integer though, right? Because it's 1, 3, 5, probably the same way, negative 1, negative 3, negative 5. Now with the calculator, of course, check your calculator always when you're doing these problems. Make sure your mode is in degrees here. Let's get this started. Ooh, this is another factoring problem. So this one is going to be 3 tangent of x, and of course tangent of x. We're trying to get to 5, so let's keep the 2 and the 3 in apart. That'll give us 6 and 1. So negative 6 plus 1 puts negative 5 in the middle. So now we have 3 tangent of x plus 1 equals 0, and the tangent of x minus 2 equals 0. Remember, we can go from negative infinity to positive infinity with this tangent, so we really don't care how big or how small the numbers are. So I get all the variables, all the numbers moved around. We get tangent of x equals negative 1/3 and tangent of x equals 2. Now, when you put this in the calculator, you get negative 18.4 when we round to the nearest tenth. You don't want that. But we do want that 18.4 degrees. So we know that tangent is negative here and here. So we're going to do 180 minus 18.4, 161.6. And then we're going to do 360 minus 18.4, so 341.6 degrees. Over here, we get a nice answer right out of the calculator, which will keep 63.4. And putting this in the third quadrant, so 180 minus that number, 243.4 degrees. For this one, 25 cosine squared x equals 4 divided by 25. And we can take the square root. So we're going to have all 4 answers here. So plus or minus 2/5. So whatever answer we get out of the calculator, we get a 66.4. And now we have to put that angle in all 4 quadrants. So 180 minus that is 113.6. 180 plus that, 66.4 that is 246.4 degrees. And then 360 minus 66.4 is 293.6 degrees. Now we're in radians. So switch your calculator to radians, and let's factor. GCF here, sine theta. So we're left with 5 sine theta plus 2. So setting each piece equal to 0. Then here we have 5 sine of theta equals negative 2. So the sine of theta is equal to negative 2/5. So it's definitely within negative 1 to 1, so we're good. When you put this in the calculator, you know the answers. These are unit circle values. You get a 0. You also have to give the other answers because we're allowed to spin all the way around the unit circle. So it's weird. You can write pi if you want to, but you're also allowed to use a decimal point and nearest thousandth. So 3.142, I guess we would round that up to. Over here, we put this in the calculator. We have negative 2 divided by 5 in there, so we get, oh, shoot, negative 0.412. Well, we don't want the negative, right? We're not allowed to use a negative answer. But we definitely want the 0.412. So we're going to put this in all the quadrants that we need. So we are going to be in these two quadrants. So that would be pi minus 0.412. So that is 2.730. And then, of course, 2 pi minus 0.412, which is 5.871. And this last problem, still in radians, so we're good. This one's kind of different. I'm gonna add the 5 cosine over here. I don't think it matters, and I'm gonna subtract the 9, so that I end up with 3 cosine of theta equals 1. Cosine of theta equals 1/3. I wanted my cosine to be positive for some reason. I don't know why. It doesn't matter. So there we have it. But that's what I did, and that's why I did it. And so our angle that we get from the calculator is 1.231. That's nice. And of course, we want that because that's in the first quadrant. And then, of course, we want to put this in the fourth quadrant. So we have to do 2 pi minus 1.231. And we get 5.052. So again, just be careful. Make sure your calculator is always in the correct mode. And not too much on the calculator portion of the test, mostly the non-calculator.